Okay, so this particular video is going to talk about perfect square trinomials. So we just did a video on factoring trinomials down, okay, and that is when their coefficient's greater than 1 or when their coefficient was equal to 1. And we had two perfectly good strategies. These perfect square trinomials certainly can be treated just like a trinomial that has a coefficient greater than 1. That's perfectly fine, but that would make it a whole lot longer and more difficult if you could recognize that the trinomial that you have before you is a perfect square trinomial, so it's special in some way. Then you're going to be able to break it down a whole lot faster without having to do all that long process that we just did in the last video. So the two perfect square trinomials have a specific pattern, and if you're able to pick them up, then you're able to save yourself a lot of time. The two examples are at the top of your page, so ax squared minus 2ab plus b squared. When we actually FOILed that out, that was a result of a minus b times a minus b. So that was a result of the exact same factor multiplied by itself. So we squared the factor a minus b. That's why it's written this way, as a minus b squared. So when you go to write your answer, you don't write x minus 4 times x minus 4. You write x minus 4 squared. And that tells us that you took that one factor and multiplied it by itself. You squared it, okay? This second one is a result of having FOILed a plus b times a plus b. And so again, it results in a plus b squared. We took exactly the same thing, and then we went ahead and multiplied it out. So you'll notice that this is a negative symbol when these are both negative symbols. Okay, exactly the same, so you have two negatives. That last term becomes a positive. And here it's a positive, and that just tells you that both of these are also positive. Okay, so pay attention to the patterns. It's very, very important. So here's my example. Since this is a negative, I'm looking at the first example where this first term represents the a squared, and this first term represents the b squared, and this negative 42x represents 2 times a and b. Okay? And so let's FOIL this out. A times a gives me a squared. So if I did that, I would get a squared, and then I would get negative ab for the outside, and then I would get negative ab for the inside, and then I would get positive b squared on the outside. So I actually have two negative ab's, and then we fix that. We don't write it that way, right? We actually put the negative in front. That's just how I was reading it, so that you could see there are two ab's, and they're both negatives. So how do you do that? How do you break it down? You need to know that this is a perfect square. So 9 is a perfect square. 3 times 3 gives you 9. X squared is a perfect square. X times x gives you x squared. 49 is also a perfect square. 7 times 7 gives you 49. So step number 1 is just being able to recognize that you have perfect squares at the beginning and at the end. And then the other thing is that the middle term is supposed to be 2 times what I would get if I multiplied a times b. That doesn't mean 9 times 49. That means what they were before they were squared. So step number 1 is to find what a and b were by finding their square roots. So you have to find a by taking that first term, 9x squared, and finding out what did you multiply by itself to give you 9x squared. So the easiest way to do that is to do it in parts. What did you multiply by itself to give you 9? 3. 3 times 3 is 9. What did you multiply by itself to give you x squared? X. X times x is x squared. So your a term is 3x. Okay? So then you do the same thing with your b. So this is a. That is what I squared where it says a squared. I took 3x and I squared it, and it gave me 9x squared. Okay? Then you're going to find your b term. Find the square root of 49. What times itself gave you 49? The answer is 7. So that is b. And when you look back at your formula, b squared, 7 squared is 49. Okay? So you're undoing the perfect squares, and then The middle term, you're just going to verify that in fact that is double the product of what a times b is. So 2ab, if a is 3x and b is 7, and I multiplied them together, I would get 21x. And then if I doubled that, I would get 42x. So my middle term, which says 42x, is in fact 2 times ab. So you use the pattern to factor down your square root or your perfect square trinomial. So your answer to factoring down a perfect square trinomial is going to be a minus b squared. So you do a, 3x, minus b, 7 squared. Okay? All right. I know that seems super overwhelming, but when we do these 4, it's going to get really, really easy. Is 4x squared a perfect square? Is 4 a perfect square? Yes. What gives you 4? 2 times 2. What gives you x squared? X times x. So that's your a term. And then you look at your b term. What times itself gives you 9? 3. So that's your a, that's your b. You need 2 a times b, right? This middle term is supposed to be double that. So 2x times 3, multiply them together, that's 6x, and double that would give you 12x. So this is a perfect square trinomial, and since it's the positive one, you look up there to which of the formulas you need, and the positive one ends up being a plus b squared. So you have a, 2x, plus b, 3 squared. Okay, let's look at number 2. Think about your foiling. I like to do it in 2 parentheses. That's just how my brain works. You can do it however you need to do it. But what times itself gives you 64? 8 times 8. What times itself gives you x squared? X times x. So that's going to be my a term, right? This is going to be my a minus b and my a minus b. And then I'm just going to write it as a minus b squared when I'm done. What times itself gives you 1? 1 times 1 gives me 1. And I'm going to put my subtraction symbols in here, right? Those are supposed to both be subtraction. And then I'm going to check to make sure that when I do a times b, 8x times 1, it gives me 8x. And when I double it, it gives me 16x. So my middle term is totally fine. I said 8x times 1, and then I doubled it. And that does give me 16x. So I'm good. I got my middle term all set. So my answer is going to be 8x minus 1 squared. Number 3, perfect square trinomial. 16, yep, 4 times 4. And yes for the x squared, x times x. And yes for the 25, 5 times 5. So I just got to double check my middle term. So that was 4 times 4 is 16, x times x is x squared, 5 times 5 is 25. When I multiply those two together, I get 20x and if I double it, I do get 40x. So I do know that that's a perfect square trinomial, and since it's a positive one, then I know it's going to be a plus b squared. Done. I would not have wanted to do the long way where a is greater than 1, and I would have had to do 16 times 25 and find the factors of 16 times 25. That gave me the 40 in the middle, and then do all of that breaking down in greatest common factors to figure out that I had a 4x plus 5 times a 4x plus 5. Could you have done it that way? Absolutely, but those numbers are huge, and it would have taken you a long time to do it. So definitely, if you can tell that these are perfect square trinomials, you're going to save yourself some time. All right, look at number 4. What times itself gives you 9? That's 3. What times itself gives you x squared? That's x. And then what times itself gives you 4? That's 2. Again, double the 3x times the 2, or double the 6x, and I do in fact get 12x. So it works. So I know this is a negative, so I'm going to have 3x minus 2 squared. And that's how you break down your perfect square trinomials. Is it absolutely necessary that you're able to notice that something's a perfect square trinomial? No. But if you can get in the habit of just checking before you start factoring, you might be able to save yourself a lot of time, especially if the numbers are really huge. That's usually a hint that you're working with some perfect squares, and you want to check it and break it down if you can first. Save yourself some time.